Okay, good evening, everyone. So we'll continue with our discussion, still on deflection method. But as I have informed you through WhatsApp and posted in classroom, we'll have a short quiz. Mga apat na problems lang naman. Susolve lang kayo tapos may, just like our activity, sulat nyo lang sa Google Forms yung answer. Okay, so that would be for problems. Good enough for 40 to 60 minutes or 1 hour, at least 1 hour. Maximum 1 hour, I think. Pero bago yan, mag-discuss muna tayo. Okay? So, we are still on deflection method and we'll continue with our discussion. We have here a simply supported beam is loaded by a couple M at its right end as shown. Locate the maximum deflection and determine its value. So we will just continue with our last meeting discussion. This one is still on double integration method. Okay, afterwards we'll proceed to area moment method. Okay, so itong gagamitin ko ngayon medyo maganda siyang one. So we have your simply supported beam is loaded by a couple M. Ito. And then it's loaded by at its right end as shown. Look at the maximum deflection and determine its value. So first we are going to compute R1. So what is R1? So if we are going to take moment at B, here in B, we can compute R1. Okay. So summation moment at B equals to 0. Okay. So let's say you have clockwise is equal to counterclockwise. So you have R1, take moment tayo dito sa B, you have R1 times L, okay, is equal to M, which is counterclockwise. Okay. M. No more moment arm kasi moment na siya. So therefore, R1 is equal to just M over L. Okay. So we have our reaction. Now, if you are going to cut section, pag mag-cut tayo ng section, okay, sabihin natin dito, cut tayo ng section dito, consider natin yung left. Okay. Of course, this distance, we don't know. That's why we're going to define this as X. So pag mag-cut tayo dito, we have this side as our moment. Okay. So the double integration method, in the double integration method, we are going to define an equation by cutting at this section. Okay. So we have here M. At this section, you have M, or the double prime is equal to moment, which is this one, okay, is equal to, what is that moment? R1, this R1, which is M over L. Okay. M over L times, what's the distance? X. Okay. So that's the moment. So that is the value of y double prime. Now, if we are going to integrate both sides, you have, this one will become the first derivative. Okay. Then, if you remember, general power formula, if you have general power formula, if you have x to the power of n, is just equal to x n plus 1 over n plus 1. So this one you have m over x, or m over l, I should say. Then you have x, your power 1 will become 2, okay, multiplied by or divided by 2. Of course, you have constant, okay, C1. So C1. This is now the equation of, this one is the equation of the slope. This is slope. This one is obviously, this one is for moment. Okay, moment cut at this section, Now, if you are going to integrate again this one, then we can come up the equation of the deflection. So obviously, if you have here, okay, let's say you have like this one. I don't know what would be the effect, but of course here it will deflect because of this moment. It will go like that. So andito yung, here's the y. Okay, maximum deflection possibly here. I don't know. Here is the y. Okay, so that's the slope that we are going to compute. I should say the deflection. So y, we integrate again. M x squared will become n plus 1 power 2 plus 1 will become 3. Okay, all over you have here L, you have 2, then another 3, 2 times 3 will become 6. Okay, you have plus C1 and then times x. If you have constant in integral calculus, when you integrate, constant will just be multiplied by x. Okay, and then you have plus C2. Okay, have C2. So from here, we have now the equation. What you are going to do next is, to substitute the value. We have this one. So we have this equation for the deflection. So we can have a relationship that when x, as you can see here, when x is equal to 0 here, this side is 0, this is 0, and then y is also equal to 0. Okay, I don't know, here, 0. We have here the x-axis, and we have here the y-axis. So this point is 0, 0. Okay? That point is 0, 0. So when x is equal to 0, y is equal to 0, meaning the deflection here is 0 because that's the location of the support. So from here, if we substitute when x is equal to 0, y is also equal to 0. Now, if we substitute in this equation, this is the equation of this deflection, okay? Deflection. So y is equal to 0, you have 0. X here, m x cube, 0 cube, and then 6L. Obviously, this one will become 0. Okay. Plus C1x, which is also equal to 0. And then you have plus C2. Thus, we can say these are all 0. C2 is equal to 0 as well. How about if we are going to look for another equation that we could compute the deflection, right? We need to compute what would be the value of this C1, okay? Because if we have already the value of C1, then we are just will be concerned of what will be the value of X. In this problem, we are going to compute the maximum deflection. Take note that the maximum deflection is located when the slope is 0, okay? Meaning when this y prime is equal to 0, you have the location of this x as maximum deflection, okay? So again, when x is equal to L, nasan? Where's that L? Andito, this side is x is L, y is 0. This is x is L, okay? This one, okay? This is x is L, and then y is 0, okay? When x is L, y is equal to 0. So we substitute y0 is equal to m L, x is equal to L becomes, x becomes L cube. You have 6L, and then you have C1 X will become L. And then earlier, we calculated that C2, okay, C2 is equal to 0. So we can just have 1, okay. Now, cube will become 2, okay. But here we divide again both sides by L, cancel this one will become 1, okay. So in other words, your C1 is equal to, this one we are going to transpose, okay. Transpose is equal to, what C1? Tama. To ML, okay? ML, may 6 pa pala dito. Negative ML over 6. Ayun yung 6, okay? So this one will just be transposed from positive will become negative. So we already have this value of C1, but the question is, where's the location of the maximum deflection? Yung sinasabi ko nga kanina, ano? I was telling earlier that the location of your maximum deflection, for example, this is your beam, okay? If you have this elastic curve, in maxima and minima, you can compute the maximum value and the minimum value when the slope is equal to 0. For example, in this case, okay, here is the location at this tangent point. This should be the location of the maximum deflection, by which this line, the slope is equal to 0. In other words, that is just horizontal, okay, line. Slope is equal to 0. Okay, so in this case, when this slope is equal to 0, that means when y prime is equal to 0, we can get the value of x to be maximum. Okay, maximum. And this is the x that we are be looking. Okay, what's that x? So we can use this formula. Okay, this y prime. Okay, we can use this y prime. So what's y prime? Okay, y prime is mx. Where's this one? Mx squared. Okay, y prime. This y prime. Okay. So when y prime is equal to 0, that is maximum slope. So what is x? Okay. So we substitute y prime. Y prime is equal to 0. You have mx squared over 2l. And then earlier we computed C1. What is C1? Minus ml over 6. Minus ml over 6. Okay. Now, we transpose. Negative ml will become positive if we put it in, okay, if we put it in the left side. So you have, or we can do the same. Actually, pwede natin makancel yung m. We can cancel already m. So you have x squared over 2l over 2l is equal to L over 6. Ito magiging 3, okay? And then this one, cross multiplication, you can have x squared is equal to L will become L squared over 3. So x is just equal to a square root of 1/3 over L. Tama ba? Or 0.577 L. So from here, we can compute na the deflection. Or x is equal to, if you calculate this one, this is 0.577 L. This is the location of the maximum deflection. Why? The slope is 0. Okay. So Let us substitute now to the deflection formula. What is deflection formula? Okay, this is the deflection formula. Again, we'll copy. Okay. So let's substitute now the deflection formula. What is now y? So y is equal to minus m over 6L. What is x? Earlier we calculated already. It's 0.577L. This is the maximum point. This is the location of the maximum deflection. 0.577 L cube. Okay. And then you have plus C1. What is C1? We have here C1 negative ml over 6 or minus ml over 6 times x. X is 0.577 L plus C2 is equal already to 0. So therefore, we can calculate. We are going to calculate here. Of course, this one is to be divided by here. May ano to dito divided by EI. Okay. So therefore, you can have y. See, this one is negative, negative. We're going to simplify. That becomes 0.0 negative, negative 0.064 ml squared. ml squared over EI. Okay. Okay, so that serves as our introduction for our before the exam, before the quiz, I should say. A question? Any question? Okay, if you don't have. Okay, so we are now going to start with area moment method. Okay, so in area moment method, if you can see this one, I think that you have to remember this formula. Okay, so let me show you in this. Okay, so if you have here the load, say you have here the load, okay, here, and then you have here the elastic curve. So if this is A, and then this one is B, and if you're going to draw a line from point A, tangent from point A, so let us just make this one, okay, exaggerate the drawing. So this one, okay, let's say this one, this is the deviation at B from A, okay. This is the angle A, okay. Example, this is your load. Now, how you're going to calculate the deviation B from A. So let's say you have your the diagram for this. Of course, you have your the reaction also here. So the diagram for this is okay. The moment diagram goes like this. You have here and this side going here like that for the reaction A. Okay, and then here for the load, it goes like this. Okay. So the deviation at B from A is just equal to 1 over EI. And then the area moment. Okay, wait, let me just charge. Okay, let me just charge. Okay, so you have here one of the EI, area moment diagram. Okay, that is from B to A or A to B, the same. Okay, and then you're going to multiply by the centroid coming from B. Okay, so for example here, the centroid is coming here, the centroid is here, so XB is going here. Okay, take note, if you're going to draw a deviation from B, for example here, this is from B, it's here, deviation at B from A, I should say this is deviation at B from A. So your centroid will also be coming from B. So this will be the centroid is coming from here. Okay. So this is the area moment diagram. See, if you're from B, division at B from A, division here, okay, from B. If you have here division at B from A, so it's also B. If it's from A, it's also here A. And then if you're going to compute for the slope, just have to compute the area, okay? No need for the centroid, wala na siyang centroid. So as you can see here, just as I have shown earlier, okay, some important notes that you're going to take. So here, the deviation, it's always started from, it is being measured from this curve, okay, from this elastic curve to the line drawn from a certain point. So this is from the tangent line, okay? This is the tangent line, this is the tangent line, and this is the elastic curve. So the deviation is from the elastic curve going to the tangent line. Okay, so what else? Area of the moment diagram. Remember, okay, last in the area for different figures in the calculation for area and moment of inertia, you have this one. Just have to take note because usually for the moment, the power ranges from second or first maybe first to second or sometimes third degree. So if we, for example, for area, if you have you are going to use this formula 1 over n plus 1 times BH. So example, if this is B and then this is H, and depending on the curve, okay? If you have the load, if you have, for example, here in the load diagram, for example, here you have here the beam. If your load here is distributed load, of course, this is 0 degree. This is zero, okay, it's 0 degree. The what's this? The degree of the curve is 0 degree, and then at the moment the shear is first degree, and then the moment is second degree. So second degree is like this one. Okay. So here this is second degree, n is equal to 2. But if your load is okay, if your load is what's this? For example, this is your load. You have concentrated load, and if you take your moment from here, let's say this is P, example, your moment in the shear diagram that becomes 0 degree, and then in the moment diagram that becomes first degree. So that is just a straight line. So that means this is just the area of the triangle. Okay, so this just to wrap up or just to show some other the formula that I just discussed earlier. Okay. So here are some basic formula in deflection for beams that you might need. Okay, no need for you not to compute anymore using uh, deflection method, just like double integration or area moment method. So these are the basic formula na dapat ma-memorize nyo na. Okay. So example here, you have if this is concentrated load, the deflection at the midspan. is PL cube over 48 EI. And then if you have uniform load, you have 5 WL to the power 4, 384 EI. If you have cantilever with load and free end, so you have this PL cube over 3 EI. Now you can use this one if there are combinations of load. Let us say a combination of uniform load and then concentrated load. So you can use the two formula. This two formula, you can use this one. So you just have to separate or you just have to do it according to parts. One thing that you have to take note, just as I said earlier, for example, if you have concentrated load P, the moment diagram is on the first degree, okay? PL going down. If this is a uniform load, WL is squared over 2 because just WL, the resultant load, okay? And then you have L over 2 here for your centroid distance. That's why you have WL squared over 2. That's negative because it's going down. And if you have moment, if you take your moment in this side, okay, in this side, if your moment is in this direction, that's counterclockwise, so it's going down, okay, it's going down, that's negative. And if you have a couple here, just like a moment, if you take your reference here in the left side, of course it's going down. But if you're going to take the reference in the right side, that's going up, okay, that becomes positive moment. Now for triangular, the resultant load here is just the area of the triangle, 1/2 as this one, W times L. And if you're going to multiply this one with the centroid, for all we know that the centroid of the triangle is 1/3 of that distance, or L over 3. So that's why you have here this centroid distance, you have the resultant force. So you have here negative WL squared over 6. That's negative because it's going down. And this is what I'm saying all about earlier, the formula that you have to consider for the area n plus 1, because sometimes the degree of the curve or the equation is already 2 or 3, so you'll have to use different formula. Centroid is also like this one. Okay. Okay, so let's say you have here this problem. Let us try to solve again. Now this time is using area diagram, a moment diagram. Okay. So if you have here this one, first we can compute the reaction. Okay, what is the reaction here? This is R, let's say R A, if this is A, okay, and if this is B, also you have here RB. So first, if we are going to take our moment from B here, okay, let's say here, so we know we need to compute for RA. Now, for us to compute for RA, we need to take moment here and the B. So we take here summation moment, okay, at B is equal to 0. That is, we simply like clockwise moment is equal to counterclockwise moment. So what are the clockwise moment? You have here RA. RA with a distance of, what is this, 3 and 6, I think. Yeah, it's 9. This one, the distance is here. This is 9, okay? 9 meters, okay? So you have here RA, okay, times 9, okay? What else? Clockwise direction, no more. So you have here 15 times this one, 6, okay? What else? This 6 kilonewton meter, you have a resultant, huh? What is the resultant? Resultant load, para mas mabilis natin ma-calculate. Okay, this is just equal to 6 kilonewton meter. Okay, 6 kilonewton meter times the distance, which is 6. So meaning the resultant load is 36. Okay, 36 kilonewton. Okay, so let's continue. You have here, again, it's counterclockwise. You have 36, and then the distance is, it is just this distance. is just 1/2 of 6 or 6 over 2. Okay, 6 over 2. 6 over 2 or you have 3. So we can compute RA. Can you please calculate RA? Ano bang value ng RA? RA. Is that 22? Yeah, it's 22. Okay, so this is 22. Kindly check na lang, and then let me notify me kung may mali. 22 kilonewton. Okay, 22 kilonewton. So if you have 22 kilonewton, then we can calculate here, or we can draw out the diagram. Okay. So in the diagram, we can have here for this RA, we take moment here. So this is just like simply this one. This one is 22, which is RA. 22 times, what is that one? Distance na 9. Okay, 22 times 9. Okay, what is 22 times 9? 22 times 9, if you have calculator, please calculate. 22 times 9 is 198. So this is 198. Yan, 198. Okay. Now, how about this one? 15? Okay, andito lang yan. Okay, you have your 15. So this one is 15 times 6. 15 times 6, 90. Okay, but this one is already negative. Okay, pababa siya. And then I will just write here, no, isa, or here possibly. Okay, that is no, starting from here. Starting from here. Okay. Okay, start from here. So what is that value here? You have 36. Okay, 36 times, what's that? 3. Okay, 36 times 3. 108. Okay. Okay, 108. Okay, so the question is to compute the deflection at a distance, okay, at a distance 3 meters from right support. So starting here, okay. Okay. So we are going to calculate the deflection from here, okay. 3 meters. Okay, so we have already calculated here. Okay, we calculated already this value. So what is deviation at B? So what is now deviation? First we have like this one, and then we have this one, and then this one. Okay, so we are going to calculate the deviation at B here. This is B. Okay. Deviation at B from A first. Okay, so what is deviation at B from A? Is equal to 1 over EI. The area moment, what is this height? It's already calculated earlier, which is equal to this one, okay? 198. So the area here is 198 times this length is equal to 9. Okay? So you have here 1/2 times 198 times 9. Okay? The centroid coming from B here, it is just 9 over 3. Okay? So times 3. That is for positive. Okay. And then you have this negative value here. Negative value here is 90. Okay. This is 90. And then this one is, I think, it's negative 108. Okay. Negative 108. Okay. So, you have here, we'll just write, sulat na lang natin negative. Negative 1/2 of 90, okay, 90 times, what is this distance? This distance is 6, okay, times 6 times, ang centroid niya is coming here, centroid niya, which is, this one is 6 over 3, or 2, okay, triangle, kaya 1/3, times 2. What else? Minus, okay, ano pa? Minus ito. What is this degree? Starting from here. Okay, dito pala. Ha? Dito kasama dito. Okay. What is this degree? If you have here, this one is 0. The next line is 1. This one is second degree. Okay, very good. Okay. Minus. Area is n plus 1. Ano? 1/2. 1 over n plus 1. Kaya nga triangle is first degree, so the area is 1/2. Kasi 1, n is 1, 1 plus 1. So this one is second degree, that becomes 1/3. 1/3 of the height, which is 108. Hindi ko na ilagay yung negative kasi dito na, negative na ako dito. Times 6. Centroid is coming here. Okay. From going here. Okay, what is that one? If the triangle is 1/3, of course, this one is, this is 2. That is 1 over n plus 2. So that becomes 1 over n plus 2, 2 plus 2, or 4. Okay, 2 plus 2, or 1/4 of 6. Okay. So this one is times 6 over 4, or 3/2.
Sir, excuse me.
Okay.
Di ba ang formula, sir, is 1 over n plus 1?
Pagka-area. Pagka-area, 1
pagka-
over n plus 1. Pagka-centroid, n plus 2.
Okay.
Okay. Kaya 4 na dito. Dito take note, pagka-area, n plus 1. Okay.
Okay.
Very good.
Noted.
Okay. Maalala mo dito. Ito yung kuha ko na okay, this one. N plus 1 pagka-area, n plus 2 pagka-centroid. Okay, so let's continue. So therefore, the deviation at B coming from A is equal to 1809 over EI. Okay, 1809 over EI. Now next, since we are looking for this deflection, ito yung tinatanong natin na deflection, 3 meters from here. This Y. So ito, what is this? This is deviation at, let us say, kung B ito, or C, sabihin natin X. Deviation at X coming from A. Okay? Itong distance hanggang dito. So, we need to determine also this one because yung deviation at X coming from A, ito yung kukumpute nating area. Ito. Okay? Ito na lang. Also here. So, what is this value? This one? What is this value? It is just, ang reaction natin dito, anong reaction natin dito? 22. So this one is 22. For example, this is number 1. This one is number 2. This one is number 3. Okay. For number 1, this is just equal to 22. Yung reaction dito is 22. Okay. 22 times distance. Anong distance? 3 and then 3 here. Okay. This one coming here. This is 6. Okay, kasi 3 dito, 6 this one, because the total is 9. So 22 times 6. Okay. So that is just equal to, okay?
132.
Yes, 132. Okay. 132 kilonewton meter. Ito naman, number 2. Yung number 2, that is just 15 times 3. Okay, yung number 2 is just 15 times 3. Okay, yan. Okay. Ito yung 15, multiply mo ng distance na, ito yung distance na 3. Okay. 15 times 3 is, tama ba? 45. Okay, 45. Okay, you have 45. How about yung number 3? Ito, yung number 3 dito. So that is the load na 6 kilonewton meter times distance na 3. So, sorry. Okay, wait. Hindi yata na siya. Okay. So again, you have the uniform load na 6 kilonewton meter times 3 times 3 over 2. Okay? Paano naging 3 over 2 yan? Ito 6 na load, and then you have to multiply by 3 distance 3, and then nasa gitna siya. Okay? Ito na kino-consider natin ngayon. Okay? 1.5 or 3 over 2 to get this number 3. So what is that? 18 times 1.5 is 27. Okay. Now, we are now going to calculate this part. Okay. That deviation. So that area. Okay. So what is that area? Deviation, yung sinabi natin kanina na x coming from A. X. Ilagay ko dito x. Ano? So ito lang i-compute natin na area. Yun na yung transfer ko dito. Okay. So you have your number 1. Yung number 1, that is 132. And dito yung 132. So we can compute now the area. So 1 over EI is equal to 1/2 of 132 times, what is this distance? Yung distance na to? This is 6 because 3 ito. So this one is 6 times 6. This is area. How about the centroid here? The centroid is just 1/3 of 6. 6 over 3. Okay, 6 over 3. How about itong negative side? The lower part. Minus 1/2 times, atong number 2, ang height is 45. And then you have the length here is 3. And then the centroid, andito banda, papunta dito. This one is just 3 over 3, or 1/3 of 3 is equal to 1. Okay. And then you have minus, again, this one is second degree. So area is 2 plus 1. Okay. 1/3 of number 3, ano yung height? 27 times 3. 3 yung base. And then you have centroid here. Ano yung centroid? Yun na yung n plus 2 over n plus 2. So this is 3. Okay. 3. Okay. Over n plus 2. If this is 2, meaning this one is 4. So madali lang tandaan, kung area mo 3, mag-increase ka lang dito ng 1 becomes 4. So deviation x coming from A is equal to over EI.
704.25.
Yes, yes, very good. 704.25. Now, how are we going to compute the deflection? Okay, so if you remember, let's just okay. Ayan, tapos andito yung line. Ito yung line ng tawag nito, elastic curve. So andito naman yung tangent line. So ito yung relationship natin. Ito yung pinapakompute na deflection at here 3 meters. Dito is 6. Okay? Ito yung distances. Ito yung deviation. Deviation B over A. Andito naman yung deviation X over A. Kasi andito yung A. And dito, this one's your deflection. Okay? So we have this triangle. Okay? This triangle, okay, is similar to this big triangle. Okay? So, small triangle first. Small triangle is just equal to y plus deviation x over a. Okay? This side. And then this side, which is 6. Okay? And then you have deviation b over a all over ito naman, yung total na length na 9. Ito mag-cancel out to. Lagay natin dito, 6 divided 3 is 2, 9 divided 3 is 3. So y is just equal to 2/3 of deviation at b from a, okay, and cross multiply, minus deviation at x over a. So, you have 2/3. Of course, may EI dito, no? I-divide na lang natin ito lahat. Anong division at B from A? Ano yung value? This one. Okay. Negative 1809. Okay. Kasi, tama yun? 1809, ano? Okay. So, you have here 1809. At wala na pala itong y kay andito na yung EI. Okay. I'll remove this one, itong EI. Na-multiply ko, na-divide na pala dito, nilagay ko yung EI dito. Pwede rin ibalik doon sa kwan. Pwede kong ilagay dito o pwede ko ilagay doon. Because the deflection here is with respect over EI. Okay? So, pwede natin ilagay yung EI. Okay? And then, minus ito, no? And then you have minus division at x from A. Ito naman. Minus din ito. Check. Okay. O, pwede na i-disregard na natin ng mga sign, ano? It's understood na going down yan siya, ano? Going down. Okay, asan na? Pwede nang disregard na lang natin yung sign. Plus, ano, minus ito. 704. Okay. Ito disregard ko ang sign, disregard ang sign, pero ito dito kasi magta-transpose, okay? Ito, lahat ito pababa siya, ito. Going down to negative, ito going down negative, okay? So ito disregard ko ng sign kasi talagang pababa siya. Okay, pero ito, disregard ko din yung sign dito, disregard yung sign, pero pag mag-transpose siya doon, magiging negative. Ibig sabihin ng input ko dito is positive, ano? Dito rin positive. Kaya lahat naman siya pababa talaga, negative talaga siya. Okay. So ito, andito na yung negative. So ang substitution dito ng division at x over a is already positive, pero magne-negative siya dahil nag-transpose doon. Okay? So ito, positive na yung 1809. And then this one, negative kasi nag-transpose. Okay? So sa substitution dito, disregard na lang yung sign because it's already always dito na pababa siya, negative sign. Okay? Just to make it clear. So this is minus kasi minus na ito dito. Okay, equals 2/3 1809 over EI, positive ito, okay? This one is positive. Okay. And then you have minus, kasi ito minus, you have 704. Okay, minus 7. 704.25 over EI. So Y, or the deflection, is equal to 501.75 kilonewton cubic meter, okay, over EI. Now, kung may value ka ng EI given sa problem, just have to substitute the EI. Okay? Sabi yung EI. So it's 10 times 10 to the power of 12. I think that, yeah, this one is power of 12 ito. Sa pagcopy lang. 10 times 10 to the power of 12. Ayan. This is 10 times 10 to the power of 12. So dito, here in computing for your deflection, you just have to substitute na the value of EI. EI, this is kilonewton per cubic meter. So dapat ang EI mo dito, na substitute, i-convert mo na rin. Okay? So you have here 10 times 10 to the power of 12. Ano? This one is from the given is 9 Newton cubic millimeter. What's this? Newton square millimeter. Ito cube. Okay? So ito convert na lang natin to kilonewton ang meter, convert din kilonewton to newton times 1,000 newton, meter times 1,000 to the power of 3. So makakompute ka ng ang value ng Y dito is 50 point, compute nyo na lang, okay? 175 millimeter. Okay? So pag millimeter na, so dapat ito convert times 1,000 ito naman times 1,000 to the power of 3. Kasi 1 meter is equal to 1,000 millimeter to the cube para maging millimeter, mag-cancel out dito yung square millimeter. Okay, so next. By the way, any question about this one? Okay lang? Okay, so let's proceed.
Sir,
Okay.
pwede magdagdag pang isang sample, sir?
Oh, mayroon pa. May susunod tayong sample.
Sa ganitong klase? Ayan, okay.
Ito. Area moment din ito. Okay? Area moment din ito. Okay? Area moment diagram din. Area moment, yes. Area moment method of deflection. Ito naman siya, nag-iba na yung value ng moment of inertia. In other words, kasi moment of inertia has something to do with the cross-section of the beam. Okay, so nagbabago siya. So this is something that you have to take note. Okay, for example, say, I show you this one. Where shall be your reference? Okay, para mas madali, dito na yung reference natin. Dito na tayo sa side na to. Okay. So, ito madali lang to ang pag-create ng diagram, pero mas madali siya maintindihan. So starting from here, going there. So this is 10 and you have here 6. So this is like 10 times 6. This one is 60, right? Kilonewton meter. And since na nagbabago yung moment of inertia at this section, mas maigi na. It's better that you have to identify this by parts. Because in the calculation, we are going to isolate or separate the calculation for each section. For example, this one, section 1, section 2. Kasi nga dito, yung moment of inertia is just half of the moment of inertia from section 2. So here, if this is 10, this becomes 30. Okay? 30. What is the question is, determine the deflection at the free end. Obviously, pagka mga fixed, mga cantilever beam, ganito yung kuwan, ano? Ganito yung what's this? Curve. What's this? Elastic curve. If you're going to draw here a line, ito yung line, andito naman yung elastic curve. dito, ang slope dito, the slope of the line tangent to the curve here, okay, papunta dito, is 0. Ito, ang slope dito is equal to 0. Kasi nga fixed siya, no? Pagka mga fixed, okay, itong tatandaan natin, pagka fixed, okay, 0 ang 1. Okay, ito, ano? Pagka fixed, ganito siya. Ang theta dito is equal to 0. Okay? Pero pagka mga hinge or roller support, ganito ang curve niya. Pag mag-create ka ng line dito, or mag-draw ka ng tangent line dito, ito hindi 0. Ano? Meron siyang given angle. So in other words, pagka fixed, angle is 0. And you can easily compute the deflection at this free end. Ito makikita, no? Visibly you will see it. This is the deflection. Okay. So in our problem, this is what we are going to calculate. Y, the deflection. By which that Y is just the same as the deviation. Kung halimbawa, this is A, this is B. Okay, that Y is just the deviation at B coming from A. And then how are we going to calculate? It's just the area of this moment, okay? Moment diagram. Ito yung moment diagram, okay? Ang area lang nito. But first, we are going to separate the section 1 and the section 2. Kasi nga dito, EI. Only I. Here, 2I. Okay? So, we calculate first for number 1. You have 1 over EI. Okay? What is the area for number 1 here? It's just the area of the triangle, the height. So we have your first 1/2. Okay? Times the height is 30. Okay? The height is 30. And then this is 3. Okay? Ayan, 3 yan. 3. What else? Ito, multiply pa pala ng centroid coming from B. Okay? So centroid here is the centroid coming from here, from B. Kasi andito yung deviation na mini-measure natin. Here, 1/3. So dito, 2/3. So 1/3 of 3 is 1. In other words, this one is 2. Okay? So multiply lang natin dito ng 2. Okay? Next, for number 2, section 2, this one, no? Number 2. So you have plus, although negative siya kasi pababa, di ba? Pero we just have to disregard the sign. Alam na natin the deflection is going down. Okay? Para di na mag-confuse. So, you have first this area, this rectangle. But take note, this is 1 over 2 EI. Kasi nga, dapat EI lang. Pero I dito, the I here is double from section 1. So, that becomes 2 EI. Okay? Times. Bracket ko. Ito muna rectangle. What is the area of this rectangle? It is just 30 times 3. 3 man ito. Okay? It's just 30 times 3. Ano yung distance from B? Ano yung distance na to? This is 1/2 of 3. Ito mula dito is 1.5. And you have here 3. That becomes 4.5. Okay? So you have here area. This is just area. And then you have distance na 4.5. Okay? This is just for rectangle. And then you have plus. Ito naman triangle. Okay? Ito, if this is 30, this is 60. In other words, this one is 30. Okay? So the area of the triangle is just 1/2 times 30 times. Ito, 3 din ito. Okay? Times. Centroid is coming from here. Okay? Dito pala. Ano yung centroid na to? What is the centroid? If this is 1/3, ito 2/3. Kung 1/3 of 3, is 1, if this is 1, so in other words, this one over here, coming here is 2. If this is 2 and this is 3, okay, 3 and then you have 2, that becomes 5. So you have here times 5. So you can compute now y or the deviation or the deflection. So this is, it's equal to 405 over EI. Okay? It's going down. Okay. Kung nilagay natin ito mga sign negative, okay, it's negative 405. It's obviously because this one, it's going down. Okay? Any question? May tanong ba? Okay lang? Okay. So we'll move on. Okay. How about this one? Itong medyo mahaba dito ang mukha. Ito muna ako. Okay. So how about this one? This is, okay, let's read. Compute the deviation of compute the deviation at B, ito, mula daw dito. Compute the deviation of B relative to the tangent drawn at A. So ito yan, ano? So ito yung tinatanong dito. Deviation at B, nag-create ka ng ito yung elastic curve mo. You project a line coming from here, going there. So ito yung deviation at B coming from A. Ito yung tinatanong sa first question. The second question, compute the deviation at D. Asan naman yung D? Ito. So ang deviation, as I said earlier, is being measured from the elastic curve. Ito yung elastic curve going to the tangent line. So that's why ito yung deviation. The other one is to compute the deflection at D. This is just, I think this one is just similar to the problem, the first problem that we calculated. Okay, so what is reaction A? Ano bang reaction A? So we can take moment at B to compute for reaction A. Example, summation moment at B, okay, is equal to 0. Clockwise is equal to counterclockwise. Ganun lang, para mas madali. You have RA times, this is, what is this? This is 1, this is 2, this one, so total is 4, okay? So you have 4 RA. Okay, what else? Wala nang clockwise. Counterclockwise, dito ang ikot natin, ito muna. 500 papunta doon, okay? You have 500 times 3. And then you have this 100 moment. So we can compute RA. Okay, can kindly calculate? See nga, 500. 15 plus 100 divide 4. Is it 400? Okay, ito 400 nga. Okay. It's 400. Ito yan. Okay. So now we are going to calculate what is the deviation of B from A. Okay. But we're going to calculate now itong deviation. Okay. So, first question is to compute for the deviation. So what is deviation of B from A? Deviation at B from A. Ito yan, ano? Ito. So area, itong mga positive area muna. Ano? Okay. This one you have 1/2. Oh, dito muna natin multiply yung EI. It's 1/2. Okay. times, okay? This is 1,200. Paano nakuha ito? Ito lang, di ba 400? This one is 400. We take our moment here. Dito tayo nag-take moment, okay? For what reason? Para maiwasan natin ito, o na 100. Okay? When you take the moment here, hindi na magre-reflect sa diagram, sa moment diagram yung 100. Okay? But if you're going to do it from here, ito magre-reflect yan. Dapat bababa siya ng ganun. Okay? Pwede din, mas madali lang din naman. But we can just continue with this method, din na mag-reflect ito. So this is 1/2. What's the height? 1,200. 1,200 times. Ano tong distance from here? This is 3, okay? 3 times the centroid. From here, okay, this is deviation at B. From here, going here, ito naman yan, okay? 1/3 of 3, ito yung 3. Dito hanggang dito is 1/3 of 3 or 3/3. Okay? 3/3 is equal to 1. Tapos meron din dito, ito naman, pupunta dito, meron din 1. That's why it's 1 plus 1/3 of 3. This is 1. Ito naman yung 1/3 of 3 na ito yan. Okay? So 1/3 of 3 is 1, so this becomes 2. Okay? 1/3 of 3 is 1 plus 1 is equal to 2. What else? Ito pa, positive. Bakit 100? Say, C, if this is 500, this is 400. In other words, RB is equal to 100 to make a total of 500 downward load. So this is 100 multiplied by 1, magiging 100 pa din ito. Okay? So, you have here, again, plus 1/2 of 100 times 100 times this distance na 1. Okay? Times. Mula dito, this one, going here, it's 2/3 of 1. Okay. Now, yung negative side naman, yung sa baba, you have minus, again, 1/2. What's this one? That's 1,000. It's just 500 times 2. Okay. You have 1,000. The base, okay, from here, going here, is equal to 2. Is equal to 2, okay, times, ano yung centroid? Andiyan naman pinakita. Yung centroid, the centroid is here. If this is 2, this is 1/3 of 2 from here. Going here is 1/3 of 2. And then you have here 1. So that becomes 1/3 of 2 plus 1 is 1.67. Okay. 2 divided 3 is 6.67. So this one is 2.67. Okay, so for the first question, deviation at B from A is equal to, what's that one? 1967. 1967. Kindly just check. 1967 over EI. So the next question, deviation at D. Okay? Deviation at D from A. Ito na, okay? This is deviation at D from A. So, ang ika-calculate natin ito lang. Okay? Itong part lang na to. Ito lang papunta dito. Okay? Asan yan? Let me copy. Okay? Okay. So, ang deviation at B, ito lang, ito lang i-compute natin. Mula dito, papunta doon. Ito lang na area. Actually, andito na yan eh. Ito na yan. Ito lang yan. So, let me just repeat para mas madali maintindihan. Deviation at B from A Yan lang na area na yan. So deviation at B from A. Ito, again, 1/2 of ito, 1,200 times this distance mula dito. What is that distance? Is 3. And then the centroid. Ngayon, ang centroid niya, kasi dito lang naman, we're just computing from here. Ito lang, ano? What is this distance? If this is 3, so in other words, this one is 1/3 of 3. Okay? So this one is 1/3 of 3. Okay? Now, the negative side minus ito naman. Okay, this one. This one. Okay. You have 1/2. Wait. Again, 1/2 area of the triangle times. This is 1,000. Ito yung height, 1,000. You have 1,000 times this distance from here going here. I think it's 2. Okay, yeah, it's 2. And then centroid. Makita mo ito yung triangle, ano? This is 2. Ito yung 1,000. So ang centroid niya is ito lang. Pupunta dito. So this is just 1/3 of 2. So it's just 2/3. Okay? You have this one area. Ito naman yung centroid. Okay, so what's the answer? 1133. Okay. Deviation B from A is 1133 over EI. Okay. Next, ano yung sa question? Compute the deflection at D. Okay. Deflection at D. What's the deflection at D? Ito ang, let me copy this one. Okay, deflection at D. So ito na yung kukompute natin. We already have this triangle. Okay, is similar to this big triangle. Okay, just like in the question before. So ano to, ito this side. This is deviation at D from A plus itong deflection at D. Deflection at D. Okay? All over itong 3 meters. Is equal to, ito naman, deviation at B. Deviation at B over A or from A equal to this big triangle. From here, going here is equal to 4 meters. It's 4. Earlier, we computed already. Division at ano ba yan? Division at B from A. This one is D from A. It's D. B from A is 1967. D from A is 1133. So we can substitute then. Okay. Division at D from A is 1133. It's going down, so hindi na natin kailangan lagay yung negative sign. Over EI. Okay. Plus itong deflection at D. All over 3. Deviation at B from A, 1967. You have 1967 all over 4. Okay? So cross multiplication, tapos ito. Okay, you have here deflection at D is just equal to 3 over 4. Okay? Over 1 or times 1967. Tapos ito punta sa kabila, magiging negative 1133 over EI na lang natin lahat. Kasi ito dito may EI naman to, may EI din ito. Ito, dito pala tama, may EI din. Okay? So we can calculate deflection D. Okay, what's that deflection D? 342. Kindly check, okay? 342 over EI. Okay, what's the unit? Okay, Newton. Usually, pagka mga Newton cubic, nasa cube yung distance, okay? Nasa cube yung distance. Kasi ang EI, okay, nasa Newton square meter yan. Okay? Kasi pagka mag-cancel out yan, ito magiging 1 na lang, meter or millimeter. Ibig sabihin, sa unit, the unit is in meter distance. Okay. Any question about this one before we proceed? May question ba? If there's none, okay, very good. Okay, how about this one? I think we'll have this one as our last problem for tonight. So ito naman, you have here a beam. Okay, let me just you have here a beam AB, okay, hinge at B, ito naka-hinge, and then it's fixed at A, given this EI, 6 meter long. Compute the moment that must be applied at B. So what is this moment B? To produce a unit rotation, take note of this one, unit rotation at B. Ibig sabihin, ito yung elastic curve mo, that will create an angle. Rotation, itong rotation, ang ibig sabihin nito is angle. Could also mean like this one. Ibig sabihin yung theta dito is equal to a unit is equal to 1. Okay? Take note about this one. Okay, so you have here, if you take our moment here, this one moment B, pataas siya, that positive. Ito naman RB, pababa, negative 6 RB. Okay? RB times 6. RB times 6, negative 6 RB. Okay, so the question is to compute for the moment B. Ito, let me just explain to you. Nalagay ko ng solution. Okay. What is this deviation B from A? If this is the curve, okay, this is the elastic curve. What's the deviation of B drawn tangent, by which your line drawn tangent from A, okay, is equal to 0. Bakit 0? Kasi ito nga yung line, okay, ito yung line, ito yung elastic curve. Sabi ko nga, pagka-fix dito, ang angle dito, the angle at this point is 0. Ibig sabihin, yung tangent line mo is horizontal line. Bakit siya naging 0? Kasi nga, okay, wala naman siya deviation, okay? Wala siyang deflection. Kasi may support dito eh. Pag may deflection, pag may support, walang deflection. So in other words, our deviation here could be calculated and could be equated to 0. So the deviation at B, okay, deviation at B coming from A is just the area of this one multiplied by its centroid. Okay, so first, positive. Ano yung positive? This is just rectangle, okay? This one is just rectangle. This is just rectangle. MB is the height, the length is 6. So parang ganito lang yan, okay? MB, height, then 6. Centroid is 3 coming from B. Okay? Here, going to that centroid. Take note, deviation at B. So, ibig sabihin yung centroid coming also here from B. So, the distance is just half of the 6. Kaya, naging 3 siya. How about this one, negative? Ano yung centroid niya? Bakit 4? Because the centroid here is 1/3. This is 1/3 of 6. Okay, if this is 1/3 of 6, this is 2. The total is 6. In other words, the remaining is 4. You have the area is the triangle 1/2 because it's triangle 6 RB. It's this side. Lagay ko na yung negative dito. Ito positive dito, okay? This one negative. Kung plus dito ang nilagay mo, then 6 RB should be negative. Okay? This is height, this is base. Okay? Ito yung 6 na base. And this one is the centroid na ito. Then we can have, from this, we can have this relationship. Kasi ito naman, siyempre, tatranspose sa kabila, magiging positive. Of course, this EI will cancel out kasi may zero dito. Pag mag-cross multiplication, that becomes 0. So we have this relationship, and thus we can also come up with this equation. Ano to? Rotation at B, yun yung condition ng problem. Take note, rotation or angle at B, pagka nagkukompute tayo ng angle, is just similar, okay? Similar to the deviation. The only difference is that, see, 1 over EI, is just similar, area lang. Ano? Pagka deviation, merong centroid. Pagka deviation, 1 over EI is area times centroid. Okay? Yun ang pinagkaiba. May centroid. Dito sa rotation, walang centroid. So you have here, we can equate this one. Rotation at B, yun ang sinasabi ng problem na unit rotation or equal to 1. Okay? So this is equal to 1. The area of this one is 6, rectangle is 6, and then MB. And then the triangle is just 1/2 of 6 RB times 6. Now, what is this? If you can observe here, MB, RB2 unknowns. But here we have RB is equal to MB over 4. So we can substitute this one for RB. So the value of RB is MB over 4. So we can compute therefore MB. MB is 800. Now, if you can compute MB, the rest of the problem, the rest of the questions will be easy now. Okay. So the second question, what's the reaction at B? Ano reaction ito? Okay. Ayan, dito na yan actually. RB is equal to MB over 4. Once you have calculated MB, which is equal to 800, RB is just 800 over 4, which is ito na yan. Okay. 200. Third question is to compute for moment at A. So, okay, moment at A, take moment ka dito, halimbawa ito, okay? Okay. Moment at A. Ang consideration mo is moment at A. Okay. Pwede ganon, okay? Ito going here. Ito naman para maging balance, dapat ito papunta naman doon. Okay? Kasi kung papunta rin dito, hindi na maging, hindi siya magbabalance. Okay? So this is just assumption that is going here. But actually, the actual answer is negative 400. Anyway, in other words, ang value ng A is papunta talaga dito. If we assume this direction, then the value of MA should be positive, meaning your orientation, your assumed direction is correct. For example, we assume like this one. Okay? So, lahat na ganitong direction, clockwise is equal to counterclockwise direction. Okay, what are the clockwise direction? Isa lang ang mga clockwise direction. RB times 6. Ano naman yung mga counterclockwise direction? First, you have MB. And then ito, na moment A, kasi in-assume natin papunta dito, which is different from the original assumption of the solution, plus MA. Okay? RB, which is equal to 200. This is 200 times 6. MB is calculated earlier, 800. 800. And then you have MA. Okay. In other words, 200 times 6 is 1,200 minus 800. Therefore, MA is equal to 400. Positive, ano? Positive siya. Iba sa dito. Because our assumption here is that moment here at the fixed end is going in counterclockwise direction. This calculation, the assumption of the direction of the moment at A is in clockwise direction. Kaya yun ang sinasabi ko. Your assumption at first, it's okay, whatever assumptions you have, because the solution will tell, the answer will tell. Okay? If your answer is negative, meaning your assumption's direction is not correct. The correct direction should be the other way around, or the opposite one. Okay? So I think that's all for tonight, not unless you have some other clarifications or query. Any questions? Andiyan pa ba?
Wala po sa akin, sir. Okay lang po.
Okay, okay. So if you have no questions, You may leave now the meeting room. Kung may question, pwede namang magpaiwan at magtanong pa.
Sige po. Thank you po. Good night.
Okay, okay. See you next meeting. I will send the solution right away. Kaya may solution na ako yung sa quiz. I will upload it in the classroom. Okay? Also, this
Thank you po.
video.
Good
Okay,
night.
okay. Okay, good night, good night. Bye.
Good night po.
all.
Good night.
Bye.
Bye-bye.